Hey guys, welcome back to another one-dimensional momentum problem, impulse and collisions 2. Suppose the force acting on a tennis ball, mass 0.055 kilograms, points in the positive x direction and is given by the graph below as a function of time. Use graphical methods to estimate A, the total impulse given to the ball, and B, the velocity of the ball after being struck, assuming the ball is served so it is nearly at rest initially. So here's the graph we're given in this problem. Okay, so we've got force in newtons on the y-axis, time in seconds on the x, and you've got, what you've got here is the impulse given to the ball, right? You've got this triangular shape. Okay, so for part A, we're asked to find the total impulse given to the ball. So if you remember in video 121, we found impulse using the definition J is equal to delta P, because by definition, impulse is the change of momentum. However, there is another way to determine it, and that is that impulse is equal to the product of force and time. Okay, so and that's the one we're going to be dealing with for part A because we have a force versus time graph. Okay, so if we say that J is equal to F delta T, hopefully this reminds you of something we did many videos ago when we were looking at the velocity time graphs. So when you saw that distance is equal to speed times time, when you had a speed versus time graph, the area under the graph represented the distance, right? So same thing here. If you have an F versus T graph, the area under the graph is going to represent impulse. Okay, so essentially what you have here is a triangle. It's 1/2 base times height. So we do J is equal to 1/2 base times height, which is 1/2 0.01 seconds times 200 newtons. Okay, so 200, you have the 2, that becomes 100. 100 times 0.01, you get 1 Newton second. So there's the impulse for part A. For part B, the velocity of the ball after being struck, assuming the ball is being served so it is nearly at rest initially. Okay, so being nearly at rest initially, it's a good approximation. That means V1 is 0. If the initial speed is 0, that means the initial momentum is also 0. Okay, so for part B, we're going to be using our conservation of momentum, impulse is equal to delta P expression that we used back in video 121. So we already know what J is. J is 1 Newton second. Delta P is P2 minus P1, and we just stated that P1 is 0. Okay, so if P1 is 0, that disappears, and so we get that 1 Newton second is equal to P2. P2 is just mv2, and V2 is what we're looking for. So divide both sides by mass, so V2 is equal to 1 Newton second divided by the mass of the tennis ball, which is 0.055 kilograms. And when you do that, you're going to get your V2 to be 18 meters per second. So that's it for this video, guys. I hope it made sense. If it did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Be sure to stay tuned next week for video 123 to be posted at 12 noon. Hey guys, that's it for this episode. If you enjoyed it, be sure to check out some of my most recent videos posted over there on the right, which you can click on your screen right now and watch. Other than that, guys, I hope you enjoy the rest of your day, and I will catch you in the next video.